aviondemand.com. Automotive training you can receive anywhere, anytime. Your online training starts here.
Okay, on the new NGC type controllers, Chrysler has gone to a natural vacuum leak detection system using what they call an NVLD solenoid. Let's talk about how it works. The computer, when the engine is running, will activate the NVLD solenoid by feed site controlling 12 volts here to the pull-in windings, which you can see is hardwired to ground. So when we energize the solenoid here, basically what that does, it shuts off the vent port of the NVLD and basically seals the tank. At that point in time, the Chrysler computer energizes the purge solenoid and obviously purges the system and creates vacuum in the tank. Now, when you typically build up about 0.3 to 0.6 psi vacuum inside a tank, what happens is the natural vacuum leak detection pump has a spring-loaded diaphragm on the vent side. When that vacuum takes over, it closes that and indicates to the computer that vacuum is now built up in the tank. Well, that's all during the enhanced evap monitor. When this monitor actually runs to check for any kind of evap leaks, it does it during key off during a cold soak, like overnight when a guy parks the car in the driveway. How does it do it? If you remember, the law of gas means that, let's just say we pressurize the gas tank going down the road during a cruise condition on the way home from work. The guy builds up 0.4 of a psi pressure, vapor pressure in the gas tank. Well, we know it's there. It's hot fuel, vaporized fuel, building up a tank, a little bit of pressure, 0.3, here again, 0.4 psi. Well, once we have ran the purge monitor and that passes, the computer says, okay, the guy's turned the key off, he's parked the car in the driveway overnight. We knew the car is going to cool off. The law of gas tells us that a pressure inside a trapped container will change as the temperature that container changes. In other words, let's say the temperature inside a gas tank with all this vaporized 0.3 psi fuel is 95 degrees. Well, the car sits cold overnight and the gas tank obviously cools down. Well, what will happen to that pressure inside the gas tank, according to the law of gases, is that pressure now, as the gas tank cools down, will now change to vacuum. So if the system is sealed with the natural vacuum leak detection pump de-energized, the vacuum vent port is now blocked. The system is sealed because, remember, the purge solenoid is turned off. We're basically trapping vacuum inside a tank if there is no leaks. Well, what will happen as this gas tank cools down overnight, vacuum is created in the gas tank. As soon as we build up about 0.6 psi of negative pressure, which is vacuum, that overcomes the spring tension of the natural vacuum leak detection vent port and opens up the vent and bleeds off the vacuum. That's how the computer on that timer function can determine if we've trapped vacuum inside a tank and there is no leaks. If we can't build that vacuum during that pressure or that temperature change from a warm tank to where it gets cold from setting overnight, if we can't build up that vacuum, we'll never be able to overcome the spring tension of the natural vacuum leak detection pump vent spring, and the spring will never close, and we obviously detect the P0455 evap leaks that way. So we don't run the monitor when the engine's running. This monitor is ran during a cold cycle or cold soak overnight with the key off to see if the system can trap and hold the vacuum for for 1 or 2 minutes anyway, to make sure there are no 10,000s, 20,000s, or 40,000s leak. Okay, the last parameter that we want to show in your scan tool has nothing to do necessarily with drivability, but it has everything in the world to do with AC. When you have an AC system that is not performing properly, we don't know if maybe the compressor is getting weak, we're not burning up enough high side pressure. One of the parameters you need to look at on your scan tool is the AC high pressure parameter on your scan tool. And the nice thing about this is that the scan tool will show you not only the voltage off the AC high pressure sensor, which is a 3-wire sensor, will also show you the actual high side pressure on that AC system. And you can see basically it's a 1-to-1 ratio. We're showing you here in this example that when the AC pressure sensor, for example, is reading 1.9 volts, 190 psi, in other words, 1.9 volts equals basically 190 psi. If you had 2 volts on the AC high pressure sensor, that's 200 psi. For example, 2.4 volts, 240 psi. So you can see it's proportional ratio that you can correlate AC pressure voltage to or AC pressure from the AC pressure sensor to the actual pressure value of that system.